Hello learners, welcome to this course on Arduino Mega Board programming and simulation. In this tutorial, I will be describing about IR based obstacle sensing with Atmega 2560 microcontroller. So Atmega 2560 microcontroller is available in the Arduino Mega Board. We are going to interface a IR sensor. When an obstacle is there, we try to sense it and send an information through UART. So first let us see the principle behind the IR sensor. So IR is a infrared, which is an electromagnetic wave. So there is a transmitter, IR LED transmitter, and there is a receiver in the module. So when there is no obstacle present, the transmitted light from the IR transmitter will not return to the receiver. Whenever there is an obstacle, the rays which are emitted from the IR transmitter will get reflected and some part of the signal will reach the photodiode. So upon reception of the return signal, an obstacle is sensed and its proximity is identified. So the distance from the module to the surface is determined. So here this sensor, IR sensor, it can measure from 2 cm to 30 cm. If the obstacle is within this range, 2 cm to 30 cm, the IR module can able to sense it. So practically we can go up to 20 cm. So here I show a typical IR sensor module where this is your IR transmitter which emits IR radiation, and this black type of device is your IR receiver which receives the IR signal coming from an obstacle. And there is a potentiometer which can be adjusted so that the measuring distance can be varied. So maximum we can go up to 30 cm distance. And it also has a LM393 operational amplifier, and it has 3 pins. A VCC can be connected with a 3.3 volt or 5 volt supply, a ground line, and a digital output line. So this digital output line will produce a 0 volt if there is no obstacle. It will produce 5 volt if there is an obstacle. So we can connect this IR module to a Atmega 2560 microcontroller. So I am going to connect it to pin number 13. So whenever there is an obstacle, this pin number 13 will go to 5 volt. If there is no obstacle, the pin will go to 0 volt. So upon receiving the signal in pin number 13, I am going to send the status to a computer using UART. So I am going to use UART 0, which is connected to your MAX232 driver. So this MAX232 driver is required because our microcontroller, it operates with different voltage range, whereas our computer operates with different voltage range. And logic 1 in microcontroller is 5 volt, logic 0 in microcontroller is 0 volt. Whereas in case of a computer, logic 1 is represented by minus 12 volt and logic 0 is represented by plus 12 volt. So there is a drastic difference between the voltage levels between a microcontroller and the computer. So I should have a level shifter, and also there should be a inverter inside. So that is taken care by your MAX232 driver. So from the MAX232, we connect it to a DB9 connector. From DB9 connector, it can go to a computer. So in this tutorial, what we are going to do is we are connected a IR sensor module. Whenever an obstacle is there, a return signal will be available on pin number 13. Upon return signal, we send the status to the computer. So now let us go and look at the circuit in your Proteus 8 environment. So here I have a Arduino Mega Board. So this Arduino Mega Board is interfaced with your IR module. So here I have a IR transmitter and a receiver. And this IR sensor module, it has 3 lines: VCC, ground, and output line. So the output line is connected to pin number 13 of your Arduino Mega Board. And I am going to use UART 0, which is TX0 and RX0 line. So this data is connected to your MAX232, which acts like a voltage doubler as well as a voltage shifter. So the output of your MAX232 is connected to the terminal window where we can visualize the data. So now let us go and see the program part. So in how to do this obstacle sensing in a circuit environment, in the sense here I have a test pin in your IR sensor module. So if I close the switch, which means an obstacle is present. If I release the switch, the obstacle is not present. So that simulated environment can be created here. Now let us visualize the programming part. Let us go to the Arduino IDE environment, where we will be writing our embedded C program. So here I have two functions, void setup function, where we will do the configuration part, and this setup will run for only one time. There is another function called as void loop, which runs infinite number of times. So it runs continuously. So here we put the logic in the loop function. In setup we try to put the configuration part. So first thing is I need to configure the serial communication. So I'm going to use UART0. So I'm using serial.begin. What is the baud rate? So baud rate is 9600 bits per second. And since I have interfaced the IR module to pin number 13, we have set that pin as an input pin. So this completes the configuration part of your circuit. Then comes the execution part. So in the execution part, I am going to check the pin number 13, whether it is equal to 1. When an obstacle is there, the pin number 13 will go to logic high. Otherwise, it will be at logic 0. So when the obstacle is there, the read of this pin number 13 will be 1 and this condition will be satisfied. Then I send the data obstacle is detected to the computer. After some 500 milliseconds, I come out. If there is no obstacle is detected, then the data no obstacle found is sent to the UART terminal. Once after completing our code, we need to compile this code. So we can compile it and convert this compiled code into a binary format. So export compiled binary. Then the X file will be created. Then we can dump this X file onto our microcontroller. So I can go to the Proteus environment. So right click on this microcontroller, edit properties. So here I can select the program file. So which is at irsensor.c.ino mega.x. So this is a hexadecimal file which we try to import into the program memory of your Arduino, and we set the clock frequency. So I have set the clock frequency to be 16 megahertz. So once I have dumped this code onto the microcontroller, let us check the logic by pressing this play button. Right now in the terminal it says no obstacle is found. So if the obstacle comes near to this proximity sensor, so that can be simulated using the switch. When I close the switch, you can see the obstacle is detected. So if the obstacle moves away, which is equivalent to this removing of the switch, then again no obstacle is found. So thereby this simple technique can be used in the automation of systems. So something like a proximity garage door opener. So in that what I can do, I can put this IR sensor module outside the garage door. Whenever a vehicle comes near, the sensor will get detected and this input will go to the microcontroller, and the microcontroller can activate a servo motor or stepper motor, thereby the shutter of the garage can open or close. So such a simple automation system can be built. So in this tutorial, I have discussed about how to interface a IR sensor module with Arduino Mega Board and how it can be used for proximity sensing. Thanks for watching. Please subscribe for more technical learning. Thank you.